I'm Astasia Myers, and I'm a general partner at Felicis, an early-stage focused VC fund based in the Bay Area. I had the opportunity to sit down with Ion Stoica, the co-founder of Anyscale and Databricks, as well as the founders of Letta, Charles Packer, and Sarah Wooters. Charles and Sarah were PhD students at UC Berkeley's Sky Computing Lab, and there they created MemGPT, an open source project that enables AI agents to have memory and state. Ion Stoica is the executive chairman and co-founder of Anyscale and Databricks. He has been a 3-time founder at Conviva, Databricks, and Anyscale, and many open source projects, including Ray, Apache Spark, and Chatbot Arena. He leads the Sky Computing Lab, where Charles and Sarah were PhD students and researchers. Well, welcome. Thank you all for doing this. It's a pleasure to have you. You all have come from academia and moved into entrepreneurship. What were some of the advantages coming from academia when you started your journey?
Yeah, well, I think startups and academia are actually pretty similar in many ways. In both cases, it's very unstructured. You kind of have to pave your own path, think very deeply about very hard problems, and no one's really going to tell you the right answer. And yeah, I think that sort of environment where you have a lot of time to think, a lot of time to work on a very unstructured problem is in many ways pretty similar to working on a startup idea.
That makes a lot of sense, kind of that research and discovery process, validation of your ideas to move forward. Maybe, Sarah, what were some of the biggest challenges coming from academia that you worked through?
I think the nature of the work is really, really different. In grad school, you spend a lot of time on research, getting to read papers. But once you have a startup, there's, of course, a lot more time on just operational things like recruiting, marketing. So I think that was a really big shift in terms of the type of work that we're doing day to day.
Makes a ton of sense. Jan, I can imagine you have thoughts. You've had many companies coming out.
Yeah. So I think there are similarities and differences. I think as a faculty, you still need to recruit and, raise money and maybe lead a lab and projects and things like that. So that's quite similar. I think the difference is pretty clear is that the academia is the ultimate incubation environment, a lot of freedom, what you are going to do, what you want to work on, the scope of the projects you are going to work on, is very diverse. When you start a company, you are going to be, by necessity, a lot more focused. And yes, at the beginning, the companies are a little bit unstructured and so forth, although you need to do some more operational work. But as a company grows, it's going to be more and more structured. And, it's like the nice thing about a company, you can put a lot of resources behind your idea, your vision, right, for long term. Not only for 4, 5, 6 years, which is how the PhD takes, but 5, 10 years or more.
Makes a ton of sense. Well, talk through kind of the process you went through when you were thinking about starting a company. What was it like working with Jan? Do you have any advice for other academics or students that want to make the transition to becoming a founder?
Yeah, well, I think for us, the transition was relatively straightforward because we've been working on this open source project. As you know, Berkeley, especially Sky and Rise Lab, are pretty famous for their open source AI projects. So that was something that kind of accompanied the research paper that we wrote at Berkeley. So there's a lot of people that were using kind of the research product in a way that was, in many ways, kind of a departure from the pure research itself. So yeah, I think actually starting the company around the research made a lot of sense. And I think also it was pretty clear to us in the PhD program while doing research that state, memory, those two things in particular were really the limitation of LM-driven AI. And those are things that need to be solved both fundamentally at a research level, but then also from a product perspective, right? I don't think developers want to use LMs, they want to use agents. Yeah. And agents are much more than just the LM.
Makes a ton of sense. I remember when I was first getting to know you that you were so involved in the community and getting their feedback on thoughts on the project and how it could be improved and what the direction could be. So really going in with that builder entrepreneur mindset if you open source something to get feedback early in the journey from users. Does that make sense? Do either of you have advice for other researchers or academics that are thinking through possibly becoming a founder, kind of words of wisdom for making that choice?
Yeah, well, I mean, I think like Jan said, like being a grad student is an opportunity to be able to explore a lot of ideas, work with a lot of different people. I think it's a really good environment to both find, co-founders, people who you're going to work with. And also it's a really good opportunity to think about what are the really important problems to be working on. Because I think one thing that Jan emphasized a lot during my PhD was that it's very important to choose the right problem to work on. And that applies both for, I think, both research and startups.
So I guess you'll do a company as a researcher and from academia if you are very passionate about what you are doing, about the problem you are solving, and you want to take it to the next level, right? That's what it is. And you don't think that there is other ways, whatever you are going to do is going to have an impact. Maybe like other companies take whatever you are doing and pushing for it. So if you really believe in what you are doing, and again, you want to take it all the way to maximize the impact, that's a very good reason to do a startup, do a company.
That makes a ton of sense. I mean, Charles alluded to this, that your work at the Sky Computing Lab has generated many very impressive open source projects. Kind of, what makes your lab stand out so much? What do you think is the difference with your lab for open source work as compared to maybe others?
Yeah. So there are a few things, right? It's many things have to come together. One thing is to have great students. Everything starts with that, right? The other thing is that about, obviously, like, I am a big believer about being pretty careful about the problem you are going to work on, right? We have limited time, limited resources, so everything being equal, the problem you are going to work on is going to make a big difference. And in the outcome. So one thing you look about in general is about trends, both at the application level, at the infrastructure level, all the way to the hardware. There are these trends which you have limited ability to impact, right? So you better understand them and to see whatever you are doing, how it fits in these trends, right? For instance, it's the need for computer large language model or deep learning in general, even before, from all the way to 2012, growing much quicker than the Moore's law, right? And the capabilities of a single machine, things like that. Or, you look at what Letta is doing, it's a fundamental thing is that like many control systems, as humans, the memory is an integral part about how we accumulate the informations and how we use this information to make future decisions. So I think that's kind of maybe the second point. The third point, I love open source because I think it's one way to maximize, and you have a chance as research, as a small group of research in academia, to have an impact, because the open source is not only about writing the code, it's about building a community. So you have a chance to build a thriving community, to work on the same project, have the same goals, on the same vision, right? So that's kind of one way to amplify your impact. The last thing I would say is that if you want, to take that and to move into, if you have an open source, with successful open source, and you want to start a company, you do have an advantage because, when you're talking about the product market fit, half of the problem is kind of solved, because if the open source is successful, this means that there are users. And if there are users, they are using it because they solve some of their problems. Now, in the second half, it's can you monetize it, right? And that's just the problem you still need to solve.
Yes. That makes, you make wonderful points around the value of open source for having bigger impact beyond yourself, bringing people along on the journey so that they can contribute to the effort. I mean, it is also a great segue to think about open source As an academic researcher, do you have any advice when academics want to open source their work, but maybe have a potential later to commercialize it? Any guidance on that process?
Mhm. Yeah, well, I think one very common piece of advice, I think it's pretty accurate, is you shouldn't be open sourcing stuff that you expect to potentially take away later. Once you make something free and open source, you should expect that people indefinitely want it to be free and open source. So I think if you have certain aspirations about monetizing your product, monetizing your code, you should probably kind of think ahead of time, like what you want to build into open source, and if you can build it in a meaningful way, where, for example, you can have like an open core, and then you can build services around it that you monetize. Of course, I think the great thing about open source is a lot of people also just do it for the love of open source, building with a community of other developers. And in that case, I think it's great to just open source everything. No, it doesn't matter what you want to build.
I guess, Jan, what techniques or strategies did you find particularly useful from your time at Databricks and Anyscale when thinking about open source?
I think that one particular technique or insights I had, quite recently, I am ashamed I didn't have this earlier on. You look at a lot of open source companies, right? And some of them are successful, some of them are not, right? Or they are not as successful as people hoped, let's put it this way. And I do think that one thing you need is, like, when you do an open source, because like we discussed, it's an open source project, so you have users, you solve a problem. Now, you need to generate, revenue, right? To get people pay for some value. So one thing is about how deep is your stack, right? The deeper is the stack, the more capabilities you have to innovate within that stack, right? Like, give you an example, like Docker. Docker is very thin. It's very hard to innovate in that layer. Something like Spark, it's much deeper. It's all the way to like SQL kind of language, right? Writing your queries in SQL, all the way to the hardware, right? So it's a lot of more things you can optimize. So you can provide better performance, better scalability, lower cost, right? The second thing, which about that is pretty clear, if the open source it's more like a framework, a distributed system, or something like that, then one reasonably easy way to start with is managed, right? Because it's harder to manage that whatever framework system, and then if you provide that people kind of a managed service, that's one good first step, right? Which this kind of distributed systems allows you to do. But eventually you have to innovate, presumably, in this stack, which is represented about your open source projects. And the deeper is, the more gives you a lot of more options.
Yep, that makes a ton of sense. Yeah, I really liked your example of thinking about a managed service and how moving from a single user and single node environment to a distributed system at scale for production, and kind of having things in the open source that helps with adoption for the individual, but then empowering them through a commercial offering that you could have to have it across the entire company. Sarah, I'm curious to learn more about Letta. How does Letta fit into the AI agent stack? And what is your vision for how Letta is having impact across AI today and future applications?
Yeah, well, I think around when we started the company, there's actually a lot of work that's been done in our lab around LLM serving. VLM is also out of the same lab. And I think we were kind of thinking, why are developers interfacing with LLMs? It seems like it makes a lot more sense if developers are instead interfacing with agents as services, as opposed to just LLMs as services or models as services. Because I think over time, there's going to be a lot more complexity that develops at this layer of memory and state management, basically optimizing context windows to get the best possible performing agents. So that was kind of the original vision that we had when we started the company, and also what we've continued to work on. And yeah, I think the way that Letta is designed, it's a bit different from other frameworks where we sort of, Letta is basically something that's deployed as a service. It's not just an agent library. So as opposed to kind of just importing Letta, you actually need to run a Letta server or connect to Letta Cloud. And I think in the future, what we envisioned is that instead of interfacing with LLM APIs, managing their own state and memory, developers will eventually be interfacing with these agents APIs and agents as services.
Makes a ton of sense. And so with that in mind and in your vision for people building across AI agents, maybe you want to talk through some of the work that the team has been doing here. You're kind of giving me a preview before we started rolling. Maybe either of you can talk a little bit about what's coming next.
Yeah, well, I think one of the amazing things about working in AI, both research and kind of production as a startup, is that like none of the abstractions are settled. So I think we all have very strong intuition that the LLM is far from a complete agentic system, and there's many, many more pieces we need to build around the LLM. The LLM is kind of like the CPU or the chip inside of a computer. So you have all these companies that are making these exceptional chips. It's kind of like the microprocessors, right? But no one has really made the computer. And I think the computer in this case is really this platform or this infrastructure layer that Sarah's talking about that kind of is LLM agnostic, and it keeps state, it keeps memories, and it lets you build agents that have state and you can run them as services. And yeah, with that in mind, we have many more ideas beyond MemGPT as to like what the real building blocks should be when you're building these systems. I think MemGPT was very much like a V1 in this direction of the operating system for LLMs, but there are many, many more ideas, in particular around scaling compute. So I think scaling compute at inference time has become an extremely popular idea, I think for very good reasons. It's another way to kind of push the limits of intelligence. But I think there's also very interesting ideas you can have around scaling compute, but not at inference time. And instead, similar to how a brain is always on, even when a human is not actually conversing with anyone. Similarly, if you have these LLM agents and they're running as services, they're always on in a data center, why not just have the agents running all the time, taking advantage of the compute they have. And that's one idea we've been working on. We've also been working on some other very exciting directions around voice. So context management, when you have in voice settings, you want very low latency. So you want these agents to be able to reply very quickly, which means you can't actually put that much information into the context window. And I think that's actually like the perfect use case for an LLM OS, because you can use the OS to basically pack the perfect amount of tokens into the context window so that the agent that is speaking, that's kind of driving the voice, is extremely fast. It has all the information it needs, and it has a very tight context window, but you have this big, larger agent or this memory manager that's making sure that all the information that the voice agent needs is always in the context window. And that's another kind of twist on this LLM OS idea that we introduced at MemGPT.
What I love about this discussion is it's clear this inspiration that you have for what you're building at Letta from UC Berkeley and being PhD students, doing this applied research to really push the bounds of what is possible with AI agents today and thinking critically about the next steps that we could be going through. It's very inspiring. I mean, you guys have direct experience in academia, working on the bleeding edge of what's coming, as well as real world customers. I'm curious, if we look ahead 2 years from now, is there a critical area of AI that will be very important that people aren't talking a lot about today, but is kind of coming and on your radars?
Yeah, so I think the scaling compute idea, kind of not at inference time, I think this is going to be huge. I think this is going to be kind of the new axis, the new scaling law that everyone kind of tries to squeeze the most juice out of. I think similarly, all these ideas, especially scaling around test time or at inference time, they're happening or they're becoming popular because we are kind of saturating the performance of the base models. And I think all these techniques, even RAG, but all of these techniques around kind of squeezing the most juice or the most intelligence out of these LLMs, they're all kind of unified by this concept of the LMOS, or kind of the context window manager. Because at the end of the day, all the LM is it's some machine, the stateless machine that takes in tokens and outputs tokens. And we're basically trying to make very, very complex compound systems out of this machine. So I think a lot of the research and the excitement in AI progress will kind of shift above the model over the next few years. And I think the real area of focus will kind of be things like scaling compute, not at test time, but at sleep time. And then also just kind of codifying all the abstractions for the LMOS. You know, what are the real system level abstractions? I think those will all become less alchemy and more engineering.
That's cool. I like that. Less alchemy and more engineering. Yeah. Jan, your lab continues to push the bounds of what's happening next. Areas that you think are critical that you all are working on.
So following up on this, I think that actually the biggest challenge in AI is and is going to be continue to be building reliable AI applications, period. I mean, you need AI application you can trust, right? It doesn't depend how sophisticated things you can do if you are not reliable, right? And the more valuable a task is, I am not talking here about arts and, you know, it's the more precise, the more reliable has to be the result. It's also, this means that there has to be a way to verify and therefore to specify these tasks. You need to specify them in order to verify what verification means. Verification means that this task has done its job according to some specification. This is true for humans as well, right? You tell an engineer, do X, you know, here is a PRD, and then you are going to get a program which actually, hopefully, satisfies the requirements in the PRD, right? So that's kind of in general. But there is another thing, because once you have the ability to verify, this makes this kind of, you know, test time compute and so forth much more powerful, right? Because if you have a precise goal, it's like humans as well. You can make much more rapid progress. That's why the most successful results in test time compute you have for domains where you do have pretty precise goals to solve, you know, problem solving, you know, math problems, coding, where you have unit tests and things like that. But overall, I think that expanding the kind of domains for which you can build, you know, reliable application you can trust, that's going to be the key. Right now, still, most of the successful applications, you have a human in the loop. Copilot, customer support, all of these things, you have a human in the loop, which basically acts like the verifier, right? Makes the ultimate decision.
That makes a ton of sense. That sounds like you're excited about scoring systems and reward modeling and valuation to get to higher reliability for more use cases. You can improve what you can, for sure. Makes a ton of sense. Well, maybe shifting gears a little bit to do a lightning round to wrap things up. Say a question, and if you guys have a strong perspective and answer, we'd love to hear from you. So maybe just to kick things off, the first question being, what's one must-read paper right now?
Sarah?
I think the sleep time compute paper.
Yeah, so that's coming soon, so people look out. Jan, any suggestions?
I would say Hipsikaron, the paper.
Great suggestion on theme with what we're talking about, inference time compute. 100%. Next question. What's your most controversial opinion about AI right now?
I think you are a dispatcher, you dispatch a question. I think you are going to see fast progress in the domains which is not necessarily controversial, like I mentioned earlier on. You are going to see really only in kind of in domains you can have precise goals, you can verify the outcomes. You are going to see a disproportionate progress in these domains versus the others.
Makes a ton of sense. We're seeing a lot of that with AI for software engineering practices.
Yeah, it's the most popular application today, the fastest growing compared with other AI applications.
Yep, 100%. And last question, maybe this will lead into more controversy.
This is for you.
Yeah, this is maybe Charles, you get this one.
You have no longer someone to redirect.
Sarah still.
Yeah. Do we have AGI in 2 years?
I think by most definitions of AGI, definitely not. But yeah, I think like Jan said, I think in narrow domains, I think, what you can do with techniques like what's shown in R1 is definitely going to lead to some pretty intense progress in some verticals. I think kind of the generally intelligent assistant that is like straight out of a sci-fi movie or something, I think that we're a little bit farther away from. Hopefully, at Letta, we're going to make some serious progress towards that. But yeah, I think 2 years is cutting a little close for that. Yeah.
Makes sense. Sarah, do you agree, or are we going to get AGI in 2 years?
I mean, I think AGI, everyone has like a very different definition for it, so it's a little hard to say. I mean, I do think the capabilities will get a lot better in the next 2 years. Like even if improvements in models kind of stalls, I think we'll just get better and better at using the models. That's a big thing that we work on at Letta, basically optimizing the context windows to try to squeeze the most juice that we can. So yeah, I think that will like see a lot of improvements. I think we're just starting to see like the beginning of agent capabilities. I think especially too, as hopefully the models get cheaper, there'll be a lot more scaling we can do, a lot more interesting things that we can do. So I think there'll be a lot of progress, but I don't know if you would call it AGI.
So I think the nice thing about not having a precise definition is that everyone is going to be right about this question in 2 years. There will be people who are going to claim we have AGI, and there are people who are going to say this is not AGI for sure.
100%. Well, Jan, Sarah, Charles, thank you so much for sitting down with me today and talking through the path for academics to become entrepreneurs, the role of open source, and what you're working on with Letta for providing state and context to AI agents. It was such a pleasure.
Thank you.
Thanks for having us.
Thanks.